Okay, a pure sample of iodine-131 decays into xenon with a half-life of 8 days. What is the ratio of the number of iodine atoms remaining over the number of xenon atoms formed after 24 days? Clearly a problem that deals with half-life. And so, whenever you have a problem like this, the typical formula that you will be using would be n over n naught equals 1/2 raised to t over t to the 1/2. Okay, so this again is a formula not presented to you in your data booklets, but it's something that you would have to remember in order to solve a problem related to half-life and such. Okay, so first things first, we take note that we are beginning this process with iodine-131. Okay, and the question is asking us, what will be the result of this particular ratio after 24 days? So one way to show or to list down what we have is I can just list the number of iodine-131 left after 24 days. Okay, and how do I express that? Well, that's going to be n naught, which I don't know. That's what we need to find. And then that is going to equal 1/2. Okay, t is 24 and my half-life from the problem is 8. Okay, so what is n going to be? N is actually just going to equal, sorry, there should be no equal sign here. There, it's going to be expressed like this. So if I move n naught to the other side, I will have n equals n naught times 1/2 24 over 8. Okay, so that's the expression I'm trying to look for. Okay, which I can simplify the following to n naught 1/2 raised to 3, but this is also just going to simplify to n naught over 8. Okay, if I simplify this. All right, so this here is my representation for iodine-131. Okay, now another thing to take note is the number of nuclei that disintegrated. Okay, this value here, this expression here, represents the number of iodine left after. How much was left after the process? So what else would I be able to kind of express depending on what this is about? If this is the number that was left over, then I could get an expression for the number that got disintegrated, right? Or got lost, if you will. Now, how do I do that? Okay, that will be your full amount, the 100%, which would be represented to the full or with the full n naught minus the value that was left over. Okay, if I find the difference between these two, then I would know that, okay, this is the number of nuclei that got lost or that got disintegrated. Okay, so if I subtract, this is a 1 whole, so this is going to be 7, the complement, over 8. All right, now what is significant about this 7 n naught over 8? This is the number of nuclei that disintegrated, which means that this is what allowed the xenon atoms to form. Okay, that's the amount that broke down, allowing for xenon to form as a result of the reaction. Okay, which is why this over here is our expression for the number of xenon atoms formed. Okay, so there. And do I have that? Yes, I have an expression for what we want in this part of the ratio, and then I also have an expression for the iodine atoms remaining, which in particular is this over here. Okay, so this one and this one are the two quantities that I will put on top of each other, simplify to get my final answer. Okay, so I'll do that here. If I put this, so that's n naught over 8 all over 7 n naught over 8. Okay, my 8s will cancel. All right, and so will the N naughts, and I will be left with 1/7, which is indeed letter B, according to the mark scheme. All right, so it could be a little challenging. Maybe you could probably start off the problem correctly by recognizing the appropriate expression for the number of iodine atoms remaining. However, if you do not recognize that the amount that got disintegrated is what you are going to use to form the xenon atoms afterwards, okay, there will be a little problem there. So the number that got disintegrated, remember, that is actually what you're using to form the result, because again, if you look at the question, the amount decays into xenon. All right, so after it breaks down, it uses that in order to form a xenon, and hence we had the following equation over here, okay, resulting to this expression for the xenon atoms formed.